In this section, we're going to use properties of logarithms to condense logs. So we're going to write the expression as a single log with a coefficient of 1. And to do this, you want to put any exponents back on first, so remove the coefficients and write them as exponents. And for any rational exponents, we're going to write those as radicals. So for our first problem, we have the sum of logs, and remember that we're going backwards, so that is the log of the product. So this one is natural log of x times 7, which is 7x. Our next problem is a difference of logs, and we can write that back as the log of a quotient. So log base 2 of 96 over 3. Now we want to see if this will simplify. It will divide evenly. So 3 into 96 will go 32 times, and you have to see if this will simplify. If you're able to rewrite 32 as 2 to a power, then we can simplify. And they don't want us to use a calculator here. So 32, if you play with it a little bit, it is 2 to the 5th. And you want to work in terms of this base. So that's what you're thinking of. So we have the log base 2 of 2 to the 5th, and now we have our property. When you have the same, your base of the log is the same of what you're taking the log of here, the answer will be the exponent. So our answer on this one is 5. This problem is also a difference of logs. So that would be the log of a quotient. So we're going to put it back together. Log in our base here is 10 of x over 2x plus 4. And I would probably put parentheses around the whole thing. This expression has coefficients that are not 1. So we will reverse the power rule and put those back up as exponents. So this will be log base b of x squared plus log base b of y cubed. And now we have a sum of logs, and that would be the log of a product. So we'll put those back together. So log base b of x squared y cubed. And you can put that in parentheses if you would like. For our next problem, I would put these coefficients back as exponents. So we're going to have the natural log of x cubed minus the natural log of y to the 1/3. And also we can go ahead and change this back to radical form. So this will be the natural log of the cube root of y. And now we have a difference of logs. So we can condense that back to the quotient. So keep your natural log of x cubed over cube root of y. For this problem, there are a couple of ways that you can start. You have to be careful and not try to just put your half up outside this whole parentheses, because your property is for just one log of something to a power, the power comes down. but this is a sum of logs. So we don't want to go with this property yet. One thing you could do, you could distribute this. And so you have a half times the log of x plus a half times the log of y. And then you can work on these separately and you can put the power back. So this would be the log of x to the 1/2 plus the log of y to the 1/2. And we can write those back as radicals. And we have a sum of logs. So this would be the log of the product of square root of x times square root of y, and those could go together. You could multiply radicals. So log of the square root of x, y. An alternate way you could have gone is to work inside the parentheses first, and you have a sum of logs. So you could have rewritten that as the log of a product. And now it is a single log, so you could put the half back up to the whole parentheses. And then it would be the square root of xy. We have one more problem that we will condense back to a single log, and we have coefficients here, so let's put those back as exponents. So we have the natural log of x cubed minus the natural log of z to the 6th plus the natural log of y to the 5th. And we're going to write this as a single log. And we have both minus and plus. So if you have the difference, then that's going to go on the denominator. So this one is going to go on the numerator. So that will be an x cubed. This one will go on the denominator. And this one will go on the numerator. So with minus, put that piece in the denominator, plus put that piece in the numerator. The change of base formula allows us to evaluate any logarithm on our calculator. Remember, your calculator has just 2 buttons for logs. It has common log, which works base 10, and natural log, which works base E. So we can convert any logarithm with any base into a common log or a log base E and then use it on our calculator. I would not try to memorize this formula just like it is. You don't need to know these A's and remember those. Just every time you're going to go into a log that you can use on your calculator. So I would just work with it as log base 10. And so you're going to take the log of the piece that's higher, that will go on the numerator, over the log of the piece that's lower, that will go on the denominator. So what I would remember here is I would take the log of 28 because that is higher than the 5. And I'm just talking about position, over the log of 5. These are both base 10, but you don't have to write that. So it's a lot easier to remember. So the log of the piece that's higher over the log of the piece that's lower. And then this can go into your calculator, and these problems will usually say evaluate to 4 decimal places, and they can tell you whether to use common logs or natural logs. If they don't say, then it's your choice. So let's enter this into our calculator. So we have the log of 28 close parentheses divided by the log of 5 close parentheses, enter. So I have 2.0704. If they ask me to round to 4 places, that is where I would stop. Let's recall our rounding rules for just a second. So if they have asked us to go to 4 decimal places, your 4 is in the 4th decimal place. You actually look at the digit to the right of it. A 5 or higher would have pushed this 4 up. Anything lower than a 5 would drop these digits off. And so that is why if I'm going to 4 places, I would put 2.0704. Next, we have the log base pi of 56. And we're going to also evaluate this one to 4 decimal places. So we will use our change of base formula. So the log of 56 over the log of pi. Let's go to our calculator again. So I will do the log of 56 close parentheses divided by the log, and you actually have a pi button. So second pi, close the parentheses and enter. And so if we're going to 4 decimal places, the 4 is in your 4th place, 2 would drop off. So for our last problem, the log base 7 of 4,391 would be the log of 4,391 over the log of 7, and then you could go into your calculator. So on our calculator we would do log 4,391 close parentheses divided by log 7 close parentheses, enter. So to 4 places, 4.3102. This 2 is not high enough, so it would drop off.